All right, this is going to be all about rational exponents. Okay, so a quick review of exponents. You've got positive exponents, but before I get to that, I do want to say what an exponent is. So let's say we have ax to the n. We're going to say that a is the coefficient, x is the variable, and n is the exponent. All right, so the a is going to be a number. It's going to be a number out in front. It's usually going to be the big number out in front, right? That's called the coefficient. And the x is going to be the variable, and the n is going to be the exponent. Okay, let's talk about positive exponents. All right, so when we have positive exponents, I'm talking about positive whole numbers, like 1, 2, 3, 4, 5, etc. So the first one is x to the 1. I can also write that as x. We also have x squared, x cubed, x to the 4th power, and so on. So those are the positive exponents. Now let's talk about the zero exponent. The zero exponents. All right, so when your exponent is 0, what does that mean? Well, that just means you're going to have a variable, and it's going to be raised to the 0 power. And anything raised to the 0 power is going to be 1, provided that x is not 0. Provided x is not 0. So you got your positive exponents, you've got your 0 exponent. Anything raised to the 0 power is 1. Anything raised to the 0 power is going to be 1. Okay? And last but not least, the negative exponents. The negatives. And I'll show you how these work. Okay, so when you have a negative exponent, what that means is you're going to have x raised to a negative number. So if you ever have x raised to a negative number, like let's say we have negative n, then what you're really doing is you have a fraction. You have a fraction where 1 is on top, and you have x to the positive number on the bottom. So what's going on here is you've got a negative exponent. You can rewrite that as a fraction where 1 is always going to be on top. So 1 is always going to be on top when we do negative exponents. And at the bottom of the fraction, you're going to have a positive number instead of a negative number. So let me give you a quick example of that. So let's say I have x raised to the negative 2 power. So how would I write this? Well, since it's negative, I would write it as a positive number in the bottom. I would write it as 1 on top, but x positive 2 on the bottom. And another one like that, let's do x to the negative 5. If I have x raised to the negative 5 power, I'm going to write that with a 1 on top, and I'm always going to have the positive number on the bottom. So that's going to be x to the 5th. Okay? So those are negative exponents. So now let's talk about what happens when your exponent is a fraction. Okay? These are going to be called the rational exponents. Rational exponents. All right, for the rational exponents, the first thing I want to say is, what does rational mean? Well, rational means fraction or ratio. So it either means fraction or ratio. In fact, that's where we get the word rational from. We get it from the word ratio. So that basically means we're going to have an exponent, and instead of it being a whole number like 2 up here or 3 up here or 4, it's actually going to be a fraction. So you could have x to the 1/2 power, you could have x to the 2/3 power, or x to the 55/54 power. So let's see how this is actually written when we do this. So here's a formula that you're going to want to remember. Okay, we're going to start off with the variable x, and we're going to raise it to the a over b power, a over b. So the top of the fraction is called the numerator, so our numerator is going to be a. The bottom of the fraction is called the denominator, so the denominator is going to be b. So this is a fraction, a over b. And the way we write this is, it's actually going to become a radical. So we're going to have a root where we have x on the inside. And really, we just need to remember what happens to the numerator and what happens to the denominator. Okay, so the numerator, the a up here, is actually going to become the new exponent on the inside. So it's going to be x raised to the a power. But then on the outside, you're going to have an index of what's the denominator. So what's the denominator over here? B. I put that as the index right here. And we're done. So this is the formula you need to remember for today. And basically all you need to know about this is the numerator, the a, right? The numerator becomes the exponent on the inside. So the numerator becomes the exponent on the inside. And down here, I'm going to say the denominator, whatever the bottom of the fraction is, the denominator becomes the index. The denominator becomes the index on the outside. On the outside. Okay, so basically the numerator becomes the exponents, the denominator becomes the index. Let me label that. This is the index. And the whole thing becomes a radical expression. So this is going to be the radical sign, the radical sign. The x is going to be the variable, and the a is going to be the new exponent on the inside. So I'll leave that up there for about a minute so you can get that. And I'm going to grab a new sheet of paper, and we'll talk about some of the problem sets. And then after we do the problem sets, we'll do a few questions on the classwork. Okay. So the first problem I wanted to do was x to the 3/4 power. So let's try this one. X to the 3/4. Okay. So this is a positive number. It's a positive fraction, right? So we've got to make sure that we write it as a radical. So I'm going to get my square root sign. Although at the very end, you'll see that it's not a square root. It's actually going to be a fourth root. And what we're going to do is we're going to take the numerator, that 3 up there, we're going to put it on the inside. So it's x cubed on the inside. And then the 4 on the bottom of the fraction becomes the new index. So this is actually called the fourth root of x cubed. The fourth root of x cubed. That's the way I would say it. Okay? And that's really all you're doing. You're just taking the two numbers and you're putting them in those right spots. Okay? Let's do another one like that. Let's do x to the 7 over 3. X to the 7 over 3. All right. My fraction is 7/3. So I'm going to get my radical sign. And I'm going to put x on the inside. The 7 on the top goes on the inside. That's going to be my new exponent. And then the 3 on the bottom, the denominator, that becomes the new index. So that goes on the outside. So this would be the cube root of x to the 7th power. But I'm not going to write that this time. Okay, so there's one more thing we can do with this. Notice that we have 7 x's on the inside, and we're taking them out in groups of 3. So what would this become in simplified form? Well, we have to ask ourselves, how many times does 3 go into 7 without spilling over? So how many times does 3 go into 7? Twice, right? So I can take out 2 x's, but I'm going to have a remainder of 1. So there's actually going to be 1 x left inside the radical. And we're done. Let me put a check mark up here too. Okay. So we've got x squared times the cube root of x. And the way I got this was I did 7 divided by 3. We know that 7 divided by 3 is 2, remainder 1. So that's how I know I'm going to take out 2 x's, but I'm actually going to have 1 x still left under the radical. And that only happens when our fraction is improper. So check this out. This fraction up here, this is an improper fraction. And if you remember what that means, that just basically means that the top of the fraction is bigger than the bottom of the fraction. And that means some of the x's are going to be able to come out. But the 3/4 up here, this is actually a proper fraction because the top is smaller than the bottom, right? Okay. Let's do 2 more examples like that. All right, let's say I have x to the 1/3 power. I've got x to the 1/3 power. So what I do is I draw my radical and I put x on the inside. The new exponent is going to be the top of the fraction, so the 1 goes on the inside. And then the 3 on the bottom, that's going to go on the outside. That's going to become the new index. So this is cube root, right? That's what the 3 means. I've got a cube root of x to the 1 power. So how would we rewrite this? Well, it's not an improper fraction, so we don't have to take x's out. We don't have enough x's to take out, right? But what we can do is we can say x to the 1 power is just x. So I can actually rewrite this as cube root of x, and I'm done. So the 1 right here, that 1 is actually understood to be there, even if it's not there. So this is called the cube root of x. Okay? Let's do one more like that. I've got x to the 1/2 power. So how would I write this? The 2 would go on the outside, and then x to the 1 power is going to go on the inside. Now, in the previous example, we said that if you have a 1 on the inside, then you just have an exponent of 1. That just means x. So really, I could get rid of the 1. But also notice I can get rid of the 2 because the 2 is already understood to be on the outside when we do square roots. So I could really just write this as square root of x, and I'm done. So this is the square root of x. Okay, so now we're going to go in the opposite direction. These first 4 examples, we went from fraction to radical, right? Fraction to radical. But this time, I want to go from radical to fraction. So that's what we're going to be looking at next. How do we go the other direction? And I've got a couple examples from the notes that I want to go over. So now I'm going to give you something like square root of x, and you're going to have to write that as x to the 1/2 power, just as an example, okay? So let's take a look at that. The first one I want to do is square root of x to the 9th. Okay, so I've got a 9 on the inside. That means that's going to become my new numerator. So there's going to be a 9 on the top of the fraction. And what's going to be in the denominator, the bottom? It's going to be the 2, right? So 9 over 2. That's my first one. Notice that we don't have an index out here. There's no number on the outside. So it's assumed to be a 2 on the outside. So we assume this to be a square root if there's no index. Okay. Let me show you one where there actually is an index. Cube root of x squared. Okay, so how would I write this as a fraction? Well, I'm going to have my variable x. The inside is a 2, so that's going to become the top of the fraction. My outside is 3, so that's going to become the bottom of the fraction. So x to the 2/3 power, and we're done. Okay, there's one more that I wanted to do before we move on to the problem sets. Let's keep that same index for now. So I'm going to have a 3 on the outside. And then on the inside, I'm going to have an x to the 5th and a y to the 4th. Okay, so what would happen here? Notice I have 2 different variables on the inside. So I'm going to have an x and a y. An x and a y. And we have to figure out what fractions are going to be on top. So for the x, I have a 5 on the inside, so that's going to go at the top. And then there's a 3 on the outside, so that's going to become the bottom of the fraction. The index always goes in the denominator, right? So x to the 5/3 power. Next, I'm going to deal with the y. So for the y, I have a 4 on the inside. That's going to be my new numerator. And then the denominator is going to be the index 3. And I'm done. Okay. Let's look at a couple of the problem sets. And then we'll do some classwork. All right, number 1. x to the 1/3. Okay, so how would I write this? So we're going from fraction to radical. So the way I would do this is I would have a 1 on the inside, I would have a 3 on the outside. So this is going to be cube root of x to the 1 power. And as you know, x to the 1 power is really just x. So I could write this as cube root of x, and I'm done. Number 2, y to the 5/6. Okay, for this one, I have a variable y, so the y is going to go on the inside of the radical. The 6 is in the denominator, so that's going to go on the outside, and the top of the fraction is going to go on the inside. So this is the 6th root of y to the 5th power. And number 3, I've got z to the 1/2 power. Anything raised to the 1/2 power is going to be a square root, so I know this is going to be square root of z. Okay. Now, usually I would write that as 2 on the outside, 1 on the inside, but we all know that this is a square root, so I just write it as a square root. The 2 is already understood to be there, and the 1 is already understood to be there. So I don't need to write it like this. Although you wouldn't be wrong if you wrote it like that. Okay, z to the 4/3. Okay, so z is going to be on the inside. The 3 is going to go on the outside. The 4 is going to go on the inside. So notice I can take out groups of 3. How many z's do I have under the radical? I have 4 z's under the radical, right? So how many times can 3 go into 4 without spilling over? Just once, right? So I can take out one of the z's, but since I have that remainder of 1, that means that one of the z's has to stay under the radical. So I've got z times the cube root of z. Okay, let's do number 5. Oh, and by the way, before I move on from number 4, the only reason why I'm doing it this way is because this fraction is improper, like we talked about earlier. All the other fractions were proper, so we didn't have to take any x's or y's or z's out. Okay, let's do number 5. All right, so 5 says x to the 1/5 and y to the 1/4. Okay, so let's do the x's first. When we do the x's, right, I draw my radical, and I'm going to have an x on the inside. And the denominator is going to become the outside, so the 5 goes on the outside, and the 1 is going to go on the inside. So I'm done with the x's. Now let's do the y's. I'm going to have a 4 on the outside, and I'm going to have a 1 on the inside. So the 5th root of x times the 4th root of y. And what I want to do with this is I want to find a common denominator. So I want to find the LCD. What does the LCD stand for? It stands for the lowest common denominator. So look at the denominators of the fractions that we have. We've got a 5, we've got a 4. So what can those numbers both become? What's the smallest number that 5 and 4 can both multiply to be? 20, right? So we're going to change the denominators into 20 so that they have that common denominator. Okay, so I've got x and I need a y. I'm still going to have two fractions, but the denominators have changed, right? They've changed both into 20. So what's the first fraction going to be? So how do I get from 5 to 20? I multiply by 4, right? So that means I need to multiply the top by 4 as well. What's 1 times 4? That's just going to be 4. So 1/5, that's actually the same thing as 4 over 20, right? Let's look at the y's now. How do I get from 4 to 20? I multiply by 5, right? So if I multiply by 5 at the top, what's 1 times 5 going to be? That's going to be 5. So now I've got that common denominator going. I changed my fractions. So now let's write it under one radical, okay? So I'm going to have my radical sign. I'm going to have x and y on the inside. And my new index is going to be the denominator, right? 20. So that's going to go on the outside. And my new exponents are going to be 4 for the x and 5 for the y. And I'm done. So instead of writing it like this, which I don't want you to do, I would rather you write it like this, where we have one radical sign and we have a common denominator. And this is kind of a special example. So this is the only one in the problem sets where you actually have to find an LCD. And that's just because the denominators are the different numbers up here. That's the only reason why you do this. Okay? Let's look at number 6. Square root of x. Okay. I'm given a radical. I need to write it as a fraction exponent. I know that the square root of x is just x to the 1/2 power, and I'm done. Number 7, 4th root of x cubed. Okay, for this one, I just write the x down, and I'm going to have 3 over 4. I can't do anything to this fraction, so I'm done. Okay, let's look at 8. 8 is the cube root of x to the 7th. So how would I write this? I would have an x to the 7 over 3. Remember, the inside is always going to be the numerator. The outside is going to be the denominator. Okay, let's do 9 and 10. Square root of what? X cubed y. All right, so how would I write this? Well, I don't have an index, so I know that the index is automatically going to be 2, right? This is a square root. So I'm going to have a 2 at the bottom of these fractions. So I have an x, I have a y, and I know they're both going to have a 2 at the bottom. So then the inside exponents are what's going to go on the top. So x has a 3, so this is really 3 over 2. And since the y doesn't have an exponent, we assume that to be 1, right? So there's going to be a 1 at the top. And we're done. Okay. That's one of those common denominator questions, right? Because they're both under the same radical. Let's do 10 now. 10 says the 4th root of what? Z squared x cubed. Okay, so I know I'm going to have an x and a z, right? The bottom of the fractions are going to be 4, since that's the index. So I know 4 is going to be in the denominator. And then the new exponents are going to go on top. So I'm going to have a 2 at the top for this one. and I know I'm going to have a 3 at the top for this one. So really it's 2 over 4 and 3 over 4. Now, what can I do with this fraction right here? I can actually reduce it, right? Because we know that 2 over 4 is the same thing as 1 over 2. So I can actually write this as z to the 1/2 power and x to the 3/4 power. And I'm done. Okay, let's look at some of the classwork. I might do 2 or 3 of the hardest problems, and I'll let you guys do the rest. Okay, so for the classwork, let's do number 4 and number 5. Okay, so 4 says we've got x to the 5/3 power. And it's saying convert from rational exponents to a radical. So we're going from rational exponents to a radical. Okay, so what's going to happen? We're going to have a cube root because we have a 3 at the bottom. And we're going to have x to the 5th power because the 5 is on top. And now what we're going to do is, since this fraction is improper, we're actually going to take some x's out. Or at least we can, right? So how many x's do I have on the inside? 5, right? What am I taking them out in? Groups of what? 3. So how many times does 3 go into 5 without spilling over? Just once, right? So I know I can take out 1x. But then how many x's are left under the radical sign with an index of 3? Okay. So how many did we say we have in remainder? What's 5 divided by 3? 5 divided by 3 would be 1, remainder 2. So I know that there's going to be 2 x's left under that radical. And I'm done. So that's the improper fraction thing. Let's do number 5. Okay, so 5 says y to the 1/2 power and z to the 1/3. This time I have 2 different denominators. So before I go ahead with this, I have to find an LCD. So I'm going to have a y, I'm going to have a z. I know that 2 and 3 can both become 6. So that's my new denominator. I've got a 6 at the bottom. And how do I get from 2 to 6? I multiply by 3. So 1 times 3 is going to give me 3. How do I get from 3 to 6? I multiply by 2. So 1 times 2 is going to give me 2. So those are my new fractions, 3 over 6 and 2 over 6. So now I have a common denominator. That means I get a common index. I can write everything under one radical. So I'm going to have y cubed on the inside and z squared on the inside. And I can't do anything else to it, so I'm done. Okay. Let's do the last one, number 10. So for number 10, what I want to do with this one is I want to convert the opposite way. I want to go from radical to rational exponent. So let me write that up here. Radical to rational exponent. So now we're going the opposite way. It's going to give us a radical, and we need a fraction as an exponent. So I've got the cube root of what? X squared z to the 6 Okay, so how would I write this as fractions? I would have an x, I would have a z, and then my common denominator is going to be 3 because that's the index. For the x's, I'm going to put a 2 on top. And then for the z's, I'm going to put a 6 on top. So there's one more thing I can do with this. Can you see it? The 6 over 3? What's 6 over 3? Wouldn't that just be 2? So really, it's z squared. And I'm done.